Now we'll come to the type of hybridization. Now we'll come to the floral diagram. So first we are going to start with sp3 hybridization. Now see the steps, children, how I am doing it. You need to do all the hybridization diagram, the floral diagram in this particular manner, in the way I am doing it. Alright, you need to do in this way. The way I am doing it, you need to follow this method. Any molecule is given to you. First, you find the type of hybridization. Any molecule like methane, ethane, carbon tetrachloride. Alright, any molecule is given because you do not know what's the type of hybridization. Here I have already written sp3, so you know it is sp3. In the exam, it will not be given to you. Alright, it will not be given to you. In exam, it will be given. Draw the floral diagram or the hybridized diagram of such a molecule. Let us say ethene, carbon tetrachloride, IF7, SF6, PCl5. In this way it will be given to you. So first thing is that you need to use the formula which I gave in my last AV and find the type of hybridization. Then you draw the diagram. It will not be given that it is sp3 or sp2 or sp or sp3d. You need to find it out first. Alright, that's the first step. Alright, okay, fine. You have done it. By using that formula, you find the type of hybridization. Alright. Now here I am giving you the formation of that is ethane molecule. Alright, now sp3, remember certain things. sp3 is tetrahedral in shape. Alright, bond angle is 109.5 degree or 109 degree 28 minutes between carbon-carbon atom. Alright, clear, remember it. Now bond length between carbon-carbon is 1.54 angstrom. Please note it down all these things, but I am saying you 1.54 angstrom. Bond length between carbon-hydrogen is 108 or 109. 1.08 angstrom or 1.09 angstrom, we can say that. Clear? It depends. There's no difference between 1.08 and 1.09, hardly any difference is there. Then that is tetrahedral, already yesterday. So all carbon-carbon single bond. Alright, all carbon-carbon single bond molecule, listen carefully, is having sp3 hybridization. Alright, it is having sp3. All carbon-carbon single bond molecule, whether methane, ethane, propane, or whatever it is. Or any molecule having tetrahedral shape. It is not a carbon-carbon. It's not a carbon molecule. Like you have seen it. Just now I gave some examples. You got sp3 where carbon was not there. Alright, so any molecule does not have carbon atom present in it or hydrogen atom present in it, but some other atom is there. Alright. And if it is tetrahedral in shape, then it is sp3 hybridized. Or if it is sp3 hybridized, then it is tetrahedral in shape. Either or. Alright, both are equal. We can say that. So from the shape we can know the hybridization, from the hybridization we can know the shape. Alright, understand it. So everything is important here. Mind it, I am saying you. So, and the carbon-carbon, the bond dissociation energy is 348 kilojoules per mole. You have to remember it. 348 kilojoules per mole. Why I am saying you? Because when I teach you after this a double bond, that is alkenes, I am going to tell you, which is trigonal planar in nature. There you will find the carbon-carbon bond, that is C double bond C. Here C single bond C is, I said, 348 kilojoules per mole. Note it down. Listen carefully. And in case of alkenes, the carbon-carbon double bond is nothing but 614 kilojoules per mole. What is the difference between alkanes and alkenes? Alkanes carbon-carbon single bond, alkenes carbon-carbon double bond, isn't it? Clear? I said na carbon-carbon double bond is 614. In double bond, one you are having sigma, another is pi. So if you subtract it, this two, you will be getting the energy for the pi bond, isn't it? So that was 348 in case of carbon-carbon single, and in case of carbon-carbon double is 614, 614. You subtract it. 614 minus 348. 614 minus 348. 14 minus 8, 6. And 10 minus 4 it is 6. That is 5 minus 3 it is 2. So 266 kilojoules per mole. You can see 266, I got it, kilojoules per mole. Whose it is? It's the bond dissociation energy of the pi bond. So it's quite less. We can say that. Sigma bond is how much I got? 348. Carbon-carbon single bond. This is your sigma bond. Carbon-carbon single bond. When I say double bond, one is sigma, another is pi. And sigma bond I got it 348. And carbon-carbon double bond I got 614. So difference of this will give you what? The bond dissociation energy of the pi bond, which is nothing but 266. It is quite less. So hence pi bond is a weaker bond. Mind it. It is a weaker bond, pi bond, so to say. Understood? And I said you already, pi bond never undergoes hybridization. When you will draw the molecular, when you will draw the hybridized diagram, you will see that in case of sigma bond, the one low will be bigger, another low will make it smaller. But in case of pi bond, both the loops will be of same sizes. I've already said you. Remember this particular points which I've said it. Alright, now let us come to the diagram of sp3. What I said, I'll take ethane molecule. Ethene. So carbon electronic configuration will be 1s2, 2s1, 2px1, 2py1 and 2pz1. The excited state, I'll take it. Alright, where 2s1, 1 electron, 2px1, y1, z1, 1 each. We can say that. Hydrogen is 1s1, so this one. Alright, 1 electron. Now, when I say ethane, ethane is what? CH3 single bond CH3. That means what you find is that if I draw the structure, it will be better for you to understand. That is CH3 single bond CH3. Now listen carefully here. Now you have to put your brain here. Alright, you need to understand it very properly. So there is a bond between carbon and carbon first of all. First this is going to take place, carbon-carbon. Alright. Then after that there is a bond between carbon and hydrogen. So what is that? First 2s, got it? 2s1 of this carbon atom will combine 2s1 of another carbon atom, because I need to draw ethane molecule. So 2s1 of one carbon atom need to combine with 2s1 of another carbon atom and it will form a bond. So how it will combine? Head-on overlapping sigma bond. Got it? So this is for 2s1 of one carbon atom and 2s1 of another carbon atom. So always remember that the first 2s1 electron in carbon atom always combines with another carbon atom to form a sigma bond, because first this has to be formed now. Carbon-carbon single bond, the main chain, the root word, the skeleton, whatever you say, has to be formed first. Then only you will be adding the hydrogen atom now. So first 2s1 of one carbon atom combines with 2s1 of another carbon atom, because another carbon atom will have the same configuration, to form a bond. So what sort of overlapping? Sigma bond, because it is sigma bond. Head-on overlapping is going to take place. Alright, this one. Now the remaining, that is the 3, 2px, 2py, 2pz, their hydrogen atom will come. Here one hydrogen, here one hydrogen, here one hydrogen. So this bond is between carbon-carbon. Got it? One other carbon will come, another carbon-carbon, and this bond is between carbon-hydrogen. So hence we got CH3. Alright, so I will write it here for one CH3. For one CH3, whatever it will be the hybridization, whatever will be the, what you can say, the diagram. For another CH3 also same thing is. Alright, so here first it is 2s1 and another, that is electron of 2s1. You can draw it in this way or you can draw upward also, downward also. This is upward, downward. It's up to you. There is no problem, because I said you, when they will come closer to each other, they will arrange itself. Alright, so if you like to draw downward, draw it, no problem. Alright, then after that you just combine this one, because now it is going to form a hybrid orbital. Understood? Hybrid orbital. This is 1s1, this is 1s1, this is 1s1, and here it is, what is that? 1 electron. This is 2px1, this is 2py1, this is 2pz1. From carbon atom we got this. This one we got it from the carbon atom, and this 2s1 from another carbon. I said you already first. This bond is going to take place, carbon-carbon, see here. And this is your CH3. Here this is hydrogen, this is hydrogen, this is hydrogen. Understood now? I think it's clear to you. The 3 hydrogen comes here and it forms CH3. First carbon-carbon bond is going to form. This is one carbon atom, from where we get it. And hydrogen atom it comes and it forms CH3. I think it's clear. No need to write this, just for your reference I wrote it. Now here what you find, 1s. Here you see, in case of carbon atom, 1s and 3p orbital participate in hybridization. 1s and 3p. So hence it is, what is that? sp3 hybridized. So you can find it out by the help of formula, and you can find theoretically also, manually also you can find it out, that how it is sp3, 1s and 3p orbitals, it's participating in hybridization. See, as I said you, 2s1 of one carbon atom combines with 2s1 of another carbon atom. First this bond, done. 2s1 over. Then 2p, 2px, 2py, 2pz, it combines with hydrogen, one hydrogen. Got it? So here one hydrogen, here one hydrogen, here one hydrogen, here also same thing, 3 hydrogens will come. So how many carbon atom, because hybridization takes place in carbon atom, no? So here how many what you can say orbitals, or which are the orbitals or which are the subshells is participating in hybridization? S subshell and 3p subshell. 1s you can see here, 1s and 3p. So hence it is sp3 hybridized. But in that way also we got it sp3. Ethane you find it out and see it is also sp3. By the help of formula you can see it is sp3 hybridized. Alright, how to find it out? See, it is very simple. I told you once again, let me tell you. C2. Now carbon 4 2s are 8. Hydrogen is 6. 8 plus 6, 14. We got it? Carbon here it is 2, na? 2 carbon. So it is 2 4s are 8. Valence electron I am saying. And here 6 hydrogen. 14. 14 and divided by 8. So 8 1s are. Got it? So it is nothing but 6. I got remainder as 6. This is Q1. This is remainder. Now remainder and divided by 3. 2. 2 3 6. Done. 1 plus 3. This is Q1. This is Q2. So Q1 plus Q2 will give the value of X. 1 plus 3 is what? 4. 4 means what? I have told you already. sp3 hybridized. What is that? Tetrahedral. Got it? In this way. So you get it by the help of formula. You get it manually also. Clear? Now after doing this. Now which are the subshells it's participating in hybridization? You can see this is your 2s. Then this is your what you can say px. If you do it in this way, this is your px. We can say this is px. Then this is your py. Sorry. This is your py, and you can take this is pz. We can say pz. This one is pz. This one I have done it smaller. I don't have the space here, so I did it in this way. This is your 2px, 2py, and this is your 2pz. Alright, 2px, 2py, 2pz, and 2s. So these are the subshells which is going to participate in hybridization. Got it? So 2px, 2py, and 2pz. You can take x as this also, y as this, and z as this. Any one you can take it. I said you that. It is nothing to do with the coordinate axis of mass. Now we'll come to very quickly the floral diagram. So this all you need to write it down. Understood, children? Don't think that I don't have to write this. No, these are the steps. First electronic configuration, then you'll write the what you can say, that spin quantum number, the diagram. Then after that you will show the type of hybridization, how it is sp3. Then you will show this orbitals which are the participating. Now I will come to the floral diagram. Now see here, that is carbon atom. So it is 2s and this is 2s. Now you might be thinking, where s is spherical, na? Yeah, that was atomic orbital. Hybrid orbital means all will be having same shape, energy and size. Listen to it. Same shape, energy and size. So hence it will no more be spherical. Because I am not combining atomic orbitals, I am combining hybrid orbitals. Understood? So hence it will be this. It will be this sort of. All it will be of same size, identical shape, size and energy. Alright? Clear? Now this is your 2s. Clear? Now it is sp3. You can write it down, and this is sigma. Clear? Now, so it is 2px, 2py and 2pz, let us say. Alright, here also same thing, 2px, this is 2py and 2pz, let us say. Now, of carbon atom, see carbon atom, this is 2s, 2px, 2py, 2pz. This is another carbon atom, 2s, 2px, 2py, 2pz. So first I have done carbon-carbon bond. Now, 3 hydrogen, this is 1, this is 2, this is 3. Alright, so this is sp3 sigma, sp3 sigma, sp3, and this is sigma. This is hydrogen, hydrogen, hydrogen. Now hydrogen will be spherical only, s1s. Understood? Alright, again the same thing. Clear? Because hybridization is taking place in carbon atom, mind it. I am saying repeatedly. So it is hydrogen, sigma, it is sigma, and it is sigma. Because hybridization takes place in carbon atom. The problem was with carbon only. The bond energy angle was different. So now X is having a bigger lobe. So the smaller lobe will be here. Y is having a bigger lobe. The smaller lobe will be opposite to it. And Z is having a smaller lobe opposite to it in this way. Alright. Same thing for here, a smaller lobe. Here a smaller lobe. And here another smaller lobe opposite to it. Now you don't say for S. Now S does not have a lobe. S is spherical. So don't draw it here. One more. Sir, for S also I'll draw it. No, how it is? Originally S subshell is spherical. S orbital is spherical. But originally P subshell, one lobe will be bigger and both the lobe were same size. But one lobe will be bigger, another lobe will be smaller, because all the three lobes undergoes hybridization. You have seen it. Px, Py and Pz. You have seen it undergoes hybridization. So one lobe will be bigger, another lobe will be smaller. See, opposite lobe I have done it. So this is the hybridized diagram. Now the equivalent diagram I will draw it here. H, 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 then H and then H here. Sigma, 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 all is sigma. Carbon, carbon you can write it down as 1.54 angstrom, and carbon, hydrogen you can write it as 1.08 or 09 angstrom, whatever you can write. And the shape is what? Tetrahedral. Shape is tetrahedral, we can say that. See, it is tetrahedral molecule, the shape is. Clear? In this way, this you got the floral diagram for ethane molecule of sp3 hybridization. This is the way you need to do for all, for sp2, sp, sp3d and all. You have to do it in this manner. Thank you.